Hi, everyone. Thanks a lot for joining us tonight, in this afternoon, and hope you all had good lunch. So what we will do today is we will do the talk called Where Should I Run My Code? And the point of this talk is to pretty much help you navigate between various compute options that we have within the Google Cloud. My name is Dmitriy Novakovskiy. I'm a sales engineer here at Google Cloud in Amsterdam. And together with me on stage later today will be Freek van de Griendt from G Company, our great partner. So quick disclaimer at the very beginning. We will have to defer questions till the very end if we have time. If we don't have time for the questions, then we will just stick around for a couple more minutes and you can catch us and ask whatever questions that you might have. We have to be strict on time here. So, before we start, I want to ask for a quick raise of hands. Can you please raise your hands if you have not yet used Google Cloud ever? Okay. That's actually good. So some of our demos will be on spot today. One more time, could you please raise your hand if you consider yourself to be on the software development side of the house? And is anyone from DevOps side of the house? Okay, that's not bad. Good. So yeah, as I said, questions at the very end. Now, what we will be doing today. Today we will do an overview of 4 main compute options in Google Cloud, including Compute Engine, Container Engine, App Engine, and Cloud Functions. The purpose of each section is to give you the sense of what each service is doing and when you might want to use it for your existing workload or for the workload that you want to consider to bring into Google Cloud at some point. Also, we will do the customer case from 10.2. Freek will present it. And at the end, we will do a recap. So to see whether we answered or not the questions on where should I actually run my code. So, there was a picture about my goal. Come on, come back. You can do it. So again, the goal is to remove any ambiguity that might be existing up until this point, and show you where to run what and where to migrate what, and also when you might want to choose certain trade-offs of one service versus another. Without further ado, Compute Engine, or virtual machines or infrastructure as a service within Google Cloud. Obviously, first of all, that's virtual machines, block storage, and networking. Like in typical infrastructure as a service framework, you can request the virtual machines via UI. You can request virtual machines via CLI clients, via the API. So all the usual goodness which is typical for public clouds. Now, a few specific traits or characteristics, I would say, for specifically Compute Engine. One is the virtual machines start very fast. So average start time is about 35 seconds. Another one is the flexibility of configuration. So within Google Cloud, you have the selection of both a set of pre-built configurations for virtual machines, including also high memory, high CPU ones, and the custom machine types. So you can resize any virtual machine to any ratio between the vCPU and RAM as much as your configuration requires. What was recently introduced, actually like months ago, is the configurations with extended memory, when now you don't have the ratio of 6.5 gigabytes RAM per vCPU, meaning that, again, if you need much RAM, few CPU, you can do that. Finally, the choice of vCPU platform. So across all the regions of Google Cloud, we run about 5 generations of Intel processors. And Skylake was the one most recently introduced. So one of the features in Google Cloud right now allows you to specify when you create a virtual machine, which is the minimum generation of Intel processors which you would like to have. And finally, this is my favorite one, is the self-service migration at no extra cost. So if right now there is some configuration running in another cloud or on an on-premise virtualization environment that you are considering to move to Google Cloud and test how it works there, we have the built-in migration tooling into Google Cloud, which adds no extra cost and which can migrate VMs from pretty much anywhere. Now, when would Compute Engine be useful? So first and obvious choice for the good fit is lift and shift. into Google Cloud. And by lift and shift, I not only mean take some legacy workload and try to move it in the cloud and get very disappointed. I actually mean any virtual machine-based configuration that runs anywhere, on other public clouds, on hostings, on anything. So anything that runs with full operating system stack on someone's hypervisor is a good candidate to be put into compute engine. Another example is enterprise workloads, maybe also requiring licenses. So things that you might be running on on-premises hypervisors, things that might be licensed on per VM basis, on per core basis. Again, good candidate for compute engine. Operating system, kernel, and performance requirements. So there are many companies, there are many pieces of software that are developed with specific stack in mind, with specific set of dependencies, with specific choice of operating system. It might be FreeBSD, actually. In such case, obviously, you would want to control the whole. You would want to control the whole compute host that you're running it into, and compute engine would easily allow you to do that. And finally, network protocols beyond HTTPS. So if the application of the service that you're putting into cloud needs to talk something that is not just plain HTTPS accessible over browser or curl, in many cases, the load balancers and the services that you will need for this will be available mainly on compute engine. Now, what would be the constraints if you choose to go with compute engine? First of all, there is certain scaling speed floor. And it's not like it's very high, so 30 seconds per virtual machine. But again, if you are going for a web scale workload and you need to be able to scale up and scale down very dynamically, it might become a constraint. And this might be the point where you would start thinking about containers if you are not doing so yet. So still good to keep in mind. Another point is self-managing configurations and updates. So when you run on virtual machines, on compute engine, Google can offload certain complexity of management using managed instance groups, when Google Cloud will take care of updating your VMs from time to time using the updated VM images. But still, the degree of things that you will have to manage within the VM is kind of higher compared to even with Docker containers. And finally, my favorite argument is, am I making the most of my VMs? Now, this is quite typical. This has been quite typical for last, I would say, 7 years as containerization and Docker were growing. Because what was happening is that people were paying quite significant money for getting virtual machines or even bare metal hosts, and keeping them underutilized. This is still possible when you are running on compute engine or any other infrastructure service platform and making not exactly optimal choice when you buy VMs and keep them underutilized. Luckily, within Google Cloud, there is a tool called right-sizing recommendations, which will indicate these things for you. So if you deployed a bunch of VMs and they are stalling most of the time, Google Cloud will recommend you to at least downsize them. OK, quick demo on compute engine. Can you please switch on the laptop? This is just a very basic one, just to give you the sense of how it looks. I will zoom in a little bit. Yep. So that's compute engine here on Google Cloud Console. All the products and services are actually called through the menu on the left. I'm getting to compute engine, and I'm going to create a new virtual machines. So I hit create instance. I decide how I will name it. Let's say it will be hello next. I decide where to place it. So the list that you see right now is the list of availability zones currently available at Google Cloud. So I will do Europe West 1D, that's Belgium. Now the configuration. So I can choose between the list of predefined types, like I told you earlier, with high memory or high CPU, or I can hit customize, and that's where all the goodness starts. So just with easily dragging and dropping, I can increase the size of VM, decrease the size of VM, and here on the right, I will be also seeing how the price estimate for it changes along the way. The extended memory feature, which I mentioned earlier. So if I don't like the default ratio on memory, I can do something like this. 360 gigabytes of RAM, 18 vCPUs. I wonder what sort of things I would be doing there. Yeah, and finally, the CPU platform. So as you see here in the Europe West 1D, I have the choice between Intel Haskell or later, or Intel Skylake or later. So let's go with Intel Skylake, the latest stuff. And I will get back to the standard configurations, just one vCPU. Then obviously I will choose the boot disk. So which operating system do I want to start there? So typical Linux flavors are available here. Also, there is Windows somewhere here, yes, 2016, 2012. And also, you can actually bring in your own images. That's also important to remember, from existing cloud or from custom-built pipeline. So it's not just limited to what Google offered here. A few quick checkboxes to enable some default firewall rules, like HTTP, HTTPS. And further on, there is a menu for doing a bunch of other things, like running startup scripts, for example, to instantiate the initial configuration of the virtual machine. We will not be doing anything here. Let's go and hit create. So while it's creating, I will mention one more thing, is persistent disks. So each virtual machine, you can attach up to, actually, I don't remember the number. You can attach multiple persistent disks to it, and they will be network-backed. So they will be placed within Google Network, attached over network, replicated, encrypted, very secure, very high performant. Obviously, the bigger disk you make, the higher throughput you will get, and if you will opt for SSD as well, because that's distributed file systems. That's just how they work. So let's get back to the demo. I have my hello next here. What I can do now is I can just hit SSH, and get to the terminal of my virtual machine. So that's the part which many folks, especially from development community, are appreciating, because Google Cloud UI is built in a way when you can pretty much skip any configurations on your own machine in order to be able to get to the VMs and resources that you're doing here. So both web shell for SSH and also what is called Cloud Console. OK, so that was a quick demo on the compute engine. Can we please switch back to the slides? Nice. So now we've got into container engine, or managed Kubernetes, or container as a service. Quick raise of hands, please. Please raise your hand if you are working with Docker. OK, half a room. And could you please raise your hands if you are working with Docker using some orchestration tools, like Kubernetes or Docker Swarm? OK, that's also very good. So, quick recap on containers for those who might not be familiar with Docker. Containerization and Docker containerization, namely, allows us to virtualize the workloads on operating system level, effectively encapsulating the application code and its dependencies into what is called container, and at the same time allowing different isolated workloads to share the same operating system kernel. What this gives us is a lot of benefits, including portability, so you can run containers in different clouds, in different Docker hosts. Also, the performance and the density. You remember the argument about am I getting the most of my VMs? When you run with Docker, you can pack much more workloads in the same VM and not care about dependencies and overlapping with them. And Docker itself is not hard to use, especially when you start practicing using docs on one machine. It's quite straightforward. It's not much harder than installing packages for Linux on top of a Linux box. Where the complexity comes is when you have 50+ Docker hosts. 50 just a random number. That's what I consider to be uncomfortable for me. So you will have to poke every Docker host individually and tell them, run this container, expose this port, connect to this port. And the whole complexity comes in when the application becomes really distributed and involved with multiple containers. So what helps here is the project called Kubernetes. So that's an orchestration platform for containerized workloads, initially inspired by Google, right now developed by many companies, including Google, Red Hat, and others. What it allows, in general, is it allows the declarative definition of application. So you don't care anymore about servers. You don't care anymore about individual containers. You just describe which components your application consists of, how they should connect to each other, how they should discover each other. And Kubernetes will take care of where to put these components within your cluster on top of Docker containers, and also how many replicas to create. So how many examples of my web server do I need? How many examples of my database do I need? And a bunch of other things like auto-scaling and load balancing. Another important point about Kubernetes is that it's multi-cloud and it's platform agnostic. So it runs on any major cloud provider and also on bare metal. So What is Container Engine? It's the managed Kubernetes offering on top of Google Cloud. It automates management, upgrades, deployment, scaling of the cluster, runs stable version, and allows you also to use so-called alpha clusters. So it pretty much abstracts all the complexity of managing cluster itself and lets you focus on the application and on deploying it. Along with that, it offers other benefits of GCP infrastructure. So global load balancing, very powerful. Multi-zone clusters, so Kubernetes clusters which will span multiple availability zones and be highly available. And also container registry and container builder. These are the things that you will need anyways when you will be adopting containers. Now, when to use Container Engine? So the great fit is obviously containerized applications, quite obvious. What I like to say is that usually teams who want Kubernetes, they ask their bosses, we want Kubernetes, we want to run in this particular platform, or we want to run on Docker Swarm or anything. So if the team has already adopted Docker, they will probably at certain scale need using Kubernetes. Another example is microservices-based architectures. So again, when one big monolith of application developed somewhere in 2000s becomes split into lots of small services. Often the amount of containers that you will have to run becomes very big, and you will need an orchestration platform. Multi-hybrid cloud, as I already mentioned, Kubernetes runs on multiple platforms, and it actually works. And again, network protocols beyond HTTPS. Next section will be App Engine, and you will understand why I'm emphasizing this, putting so much emphasis on it so far. Bad fit or constraints, you can run only containerized workloads, so you cannot run virtual machines on Kubernetes. Actually, technically you can, but it's not outside of scope of this talk. Services-oriented architecture, that's kind of the opposite side of microservices-based architectures. So it's not like you will want to, you will have to refactor the application and split it into services in order to be truly efficient on Kubernetes. You will not want to put like old monolith, which doesn't scale horizontally on Kubernetes and just get more complexity for yourself. So the application has to conform also. And finally, imminent CI/CD pipeline. Continuous integration, continuous delivery. If you will start producing your own containers and deploying them at scale, you will need all the grown-up practices of staged deployment, development, automatic testing, and things like this. So Kubernetes is it's a sort of a prerequisite for it. And one piece before we get into customer case is App Engine. So App Engine is what we call an original Google Cloud. It started back in 2008, before we had the rest of the things. And it's a platform as a service offering for Google, which follows the mentality of code first, UX for developers. So with App Engine, we used to want, and we still want, and we still do it, let developers focus purely on code, deploying the code, and no additional infrastructure management required around whatsoever. The trade-off for it is that App Engine has obviously certain ways of how the applications have to be written to be able to run on it, and sometimes it enables some things, sometimes it may put additional constraints. But the code-first UX gets you to the first deployment in no time, with no learning curve. So yeah, fully managed no-ops infrastructure, load balancing, scaling, everything is taken care of. And what's important is the lowest entry barrier and shortest learning curve. So Kubernetes is friendly to developers, and it gets even more friendly to developers with time. But still, like in my experience and experience of many people, when you start learning Kubernetes, you have to get into this whole world of Docker containers, service discovery, service management, a lot of load balancing, its own object model, which is quite nice and gets you additional experience. But if you want to deploy something faster, or if you're not interested in infrastructure at all, the barrier of entry on App Engine is much lower. So App Engine has multiple runtime options across across two tiers that it has, standard and flex. What runtime means is that what sort of language environment can App Engine support for you. So today it's multiple versions of Python, multiple versions of Java, multiple versions of Go, and most importantly is .NET and also custom runtimes. Custom runtimes have been introduced recently with App Engine Flex. And what happens is that App Engine Flex runs your workloads not like standard one, which used underlying Google's infrastructure, Borg, to run your workloads. But it runs Docker containers within the virtual machines. So you see the similarity with Kubernetes to some extent. And this also enables customized runtimes. So if some language is not supported by App Engine at the moment, this can be added by you, by Google, by third parties. That's possible. The coolest, personally, for me, thing for App Engine is how the traffic splitting works. That's something that I will show in the demo. So all the load balancers available within Google, in my opinion, are very cool and very powerful. But this one, it just works magic. So doing A/B testing and shifting traffic between the versions is literally happens on the wave of your hand. And also, App Engine also supports microservices architectures. So we just talked about it in Kubernetes section, that the application is getting split into smaller parts and services talk to each other. You can also do it in App Engine in a slightly in a slightly less flexible way, because App Engine has certain restrictions that it puts on terms of how the code has to be structured, how many applications you can have, how many services you can have within an application. But still, it is possible, so you don't have to run monoliths on App Engine. But if you're running, if you plan to develop something new, if you want to use gRPC and not just HTTP invocation, probably you would steer towards Kubernetes. OK, so when to use App Engine? Good fit. Applications that only need HTTPS request and response. That's the pattern together with stateless serving applications. That's the pattern for App Engine. That's the web-facing applications that usually don't need to talk anywhere but northbound to the users that come in. Mobile and web backends. So many of our signature customers running at very large scale have been using App Engine to scale horizontally very fast, very reliably, and speed up the development with this. Again, because the runtimes that we offer are sufficient for it. Rapidly scaling to high traffic, what I just mentioned, especially on App Engine standard, which runs on underlying Google infrastructure, as I mentioned to you, the time of scaling is very fast. So new instances can be added almost instantly, even faster than containers. What are the constraints? So let's say I have a web app, right, or the mobile backend, whatever. What will I have to deal with on App Engine? First of all, if I choose App Engine standard, which scales faster, costs less, but has more restrictions, I will have a set of predefined runtimes, and I will not have an option of custom runtimes. So if my runtime is not available for App Engine standard, I will not be able to use it, or I will have to change my runtime. Can't use third-party binaries. Quite obvious. The same way how restricted network and file system access works. So when you run on App Engine standard, you cannot write into your file system. And the only network connectivity that you can do is an outbound to the internet. You cannot talk within Google Cloud, only with the APIs. You cannot talk with, well, it's pretty much like web-facing hosting. On Flex, it's a bit more relaxed. So first of all, obviously, you have standard Docker constraints. So if it cannot be put into Docker image, it will not run on App Engine Flex. And second is no scale to zero. So App Engine standard can do the scale to zero trick. When there is no traffic, it will scale to 1 or even 0 instances. Flex cannot do it. So Flex runs on virtual machines, so you will always have to maintain some sort of capacity. So if you're developing something that you want to keep on the free tier and on a low traffic, probably App Engine standard is a better choice. And again, as I mentioned earlier, if you're starting with a new application, if you have an environment where dev and ops are working very closely, and we'll talk about it a bit later, if you don't yet know how much it will scale in terms of amounts of components and the size of the team, when choosing between App Engine and Kubernetes, make sure that the structure of projects in each of the platform will allow you to work with it. Kubernetes will be very flexible. You can use multiple container registries. You can use multiple namespaces, multiple Google Cloud projects. App Engine is more prescriptive. So you have one application per project, multiple services within the application, and multiple versions of the services. For someone who just wants to do the code first and knows the scope of the development for whatever, next half a year or 12 months, it's enabling. It makes you work faster. It makes you care less about things that you don't want to care about. If the level of uncertainty is higher, it might happen that it makes sense to invest in getting up with Kubernetes. OK, so quick demo on App Engine. Can you please switch to the laptop? This will be actually faster even. OK, so here I have my App Engine dashboard, and it failed to load because I don't have Wi-Fi. Interesting. Let's try again. Oh, I'm not supposed to have the Wi-Fi. I'm on wired connection. Anyways, so I have the. Just a second. I will still check the connectivity because it seems like I'm having a bit of trouble here. OK, so I lose the wire connection. I will try to do it through the Wi-Fi. I lost the wired. That's not something that you would expect. OK, so I have my App Engine deployment, and I have 2 versions of my application running. Let's wait for it to show up. Nope, no chance. Yeah, we will not get there. OK, we'll skip the App Engine demo because of the networking part. Please switch back to the slides. Sorry about that. So before we hand over to the customer example, I will tell you the story about the App Engine demo. So over there, I have an application running in 2 versions, which each of them displays a different version of the website. Very simple one, like Hello Next Amsterdam. So I had to relay this message to you. You remember I mentioned the load balancer with the traffic splitting. So when you run with App Engine and you deploy a new version of a website or a web application or whatever, your e-commerce store, it's very easy to shift the traffic in natural value, like what is the percentage of the users which I want to go to version 1, what is the percentage of the users which I want to go to version 2. So this both enables you to easily deploy new versions, roll back to them, and test them, like do sort of A/B testing between the users. That's the user experience which is available right now mostly on App Engine and similar platforms. Because when you run on Kubernetes, for example, you have to scale blue-green in a more involved fashion. So yeah, if the runtimes fit you, I recommend you try it out. OK, so I will hand over to Freek now to present the customer example of Ten2.
Thank you. Dmitriy, for having me. Really a pleasure to be here. So I'm Freek from Griendt. I'm a director at the company. We are Mike. Now it's working. Thank you. So I'm Freek van Griendt. I'm a director at G Company. We are a premier Google Cloud partner, and we give trainings on all of this fancy technology for all your developers and DevOps out there. We actually have a booth here where you can get a discount on our training. So please check it out. It's in the main hall. But I'm not here today to pitch you about our training. I'm here to tell you about a customer example in Ten2. So you've seen many examples of really cool technology. And actually, what I wanted to show you today is what you can do with it in a very simple case, which is Ten2. Ten2 is a payrolling company active both in the Netherlands and in Belgium, and they have a focus on the artistic and event sector. Now, just to tell you something about what they do is they manage the part-time employment for people, so working in the artistic sector and doing events like students guiding the people around here. That's typically the activities that Ten2 does. They, just for your information, they manage the part-time employment of about 5,000 people on an annual basis just in Belgium, and they do this with a team of 15 people only. So that's full operations. So they are one of the first payrolling companies, and they've been doing this for years, to rely heavily on their digital platform, which they call My Ten2. So we've engaged with them since the end of 2015, and when we first met them, they had a couple of challenges. So first of all, their infrastructure was completely outdated. It was a mixture of 6 applications that were all patched together with old-fashioned integrations. And worst of all, these applications were actually inherited from the Dutch mother company. So it was very, very difficult for Ten2 to follow with Belgian legislation. If you do payrolling in Belgium, if you know anything about it, it's quite complicated, much more complicated than in the Netherlands. So it's a big challenge, let alone that they could innovate towards their customers. So their customers go in this platform and create contracts on a daily basis. So the more modern, the more usable the platform is, the bigger their competitive advantage, which they want to increase over time, obviously. So Ten2 is I just mentioned it's 15 people, so it's a small company. It's an SMB. They don't have any dedicated IT or network administrators in-house. So sometimes were just facing with the fact that their internet connectivity went down, and so customers were not able to create contracts just for a full day, which obviously was for them it was a legal nightmare because you have to comply to certain DMONA standards, etc. It's all very complicated. It's bad. So basically, we went and go and advise them on how we could solve this challenge using Google technology, and that's what I want to focus on today. So we have built for them a web application. So it's a modern web application that basically works on any device. We've used the App Engine for that because of many of the reasons that Dmitriy just highlighted. It's just we didn't want to have anything to do with moving servers or maintaining them, maintaining versions, whatever. We just wanted to start coding. So it's backend, frontend split. So the backend is in PHP, which was a requirement by the Dutch mother company because they wanted to have some audibility and they have some PHP in-house knowledge there, which for us was fine. I mean, App Engine was able to run that. And in the front end, we're using Angular, also Google-sponsored technology, and we chose that mainly because of the wide developer audience there is for Angular. I mean, if you have really hardcore JavaScript developers, you can discuss whether it's the right framework to use. It was a very, very usable one for us. Scalability is super interesting as well. The load on Ten2's web application is pretty much, 24/7, a little bit lower in the weekend, but it's pretty much constant 24/7, except for, and it's really just a handful of high-volume customers that are using a functionality they call timesheets, where they want to create like 1,000 contracts in one go. And for that, obviously, when such a timesheet is created, App Engine automatically scales up, creates new instances, and when the timesheet is fully processed and checked with all of the minimum wages and all the payroll logic that's behind it, App Engine automatically scales down. Pretty powerful for Ten2. Secondly, we use Cloud SQL as a reliable database. We had choices of database. Obviously, we chose a relational one, basically because we want to do a lot of complex querying, and we have pretty high volume of records, but not that much that you would be looking into, like a BigQuery or a Cloud Spanner that wouldn't make much sense for Ten2. All of the contracts and basically all the files that are exchanged with customers and the people that are employed, so that's employment contracts, pay slips, invoices, they're all stored on cloud storage. So we've built this application in about a year. We migrated 5 years of data, and now we've been live for about a month, and there's 500,000 files on cloud storage, obviously without any degrade of performance and requiring no server space on-prem. There are still some highly specialized applications in the on-premise network. One of them is the payroll engine, the other is the accounting software. And we've built interfaces with those applications. It's basically standard web services as well as FTP file exchange. Still pretty old-fashioned. In this project, we've also moved a really horrible legacy application to the cloud, which was basically trying to do a mix between customer support as well as CRM, which we've covered with Freshdesk and Freshsales. These are both G Suite recommended applications as well, so it's a really nice match. And we integrate with them two-way. We have built a two-way sync using standard APIs from those products, as well as APIs that we built in App Engine and choose to expose for those specific integrations. In terms of reporting, there is we at Ten2 wanted to have some kind of BI functionality as well. So we have evaluated several platforms. We looked into Tableau, which was quite heavy for the solution that Ten2 was looking at. Then on the other hand, Cloud Data Studio, also integrated with G Suite, was a little bit too limited. So we chose to go for Periscope. Periscope is a SaaS platform that you just connect to your database. It's just you IP connect to the Cloud SQL, and then you will be creating nice-looking dashboards that you can send to people in a matter of hours, really. So that's about the architecture that we're on right now. So again, we've rebuilt the entire application from scratch in less than a year, and we've been live now for about a month. We're still in hypercare, so still facing some post-go-live issues, as you always do. But we use the versioning of App Engine actually for that. So we push a new version to production at least once a day, and then while we deploy this new version, we split the traffic between the internal people of Ten2 so that they can run on a new version, while customers are still on the older production version, which is like a form of A/B testing. And as soon as we know that there are no bugs anymore, that's actually when we move all of the traffic to the latest version. So that works pretty nicely in App Engine as well, without us being experts on the subject. So what's next for Ten2? Obviously, we still have those on-prem applications. That's payroll engine, which is pretty sophisticated. It's an application running on .NET, so we're very happy to hear that since recently we're also able to move that to Compute Engine. Secondly, Ten2 is still using old tape storage for their full historical archive of invoices and contracts that they want to move to the cloud as well. And lastly, there's actually a parallel session going on about Apigee. Apigee is a platform for managing and developing APIs. And given that the new MyTen2 runs APIs, we actually want to consider using Apigee to see to which degree they are used, because some of these high-volume customers from Ten2 that I mentioned are actually, they have their own IT infrastructure, and they actually want to create the contracts through API. So we would be using Apigee to monitor the traffic as well as what would any errors that might occur. So that was the most important thing I wanted to share on how we use this wonderful technology, and I'll pass it back to Dmitriy now. Thanks.
Okay, so now, as a matter of a bit of dessert, we have one last service called Cloud Functions. And Cloud Functions allows us to deploy the code which will be executed based on the event, with no infrastructure involved and with actually no even the notion of server or application involved. So what this means, we get the serverless environment to build and connect cloud services. Fully managed execution, so all the functions that are written, they execute in Node.js environment, and you pay per execution time. So you don't even pay for like constant uptime. What event-driven means? Event-driven means that you write a function. Let's imagine that this is a function that adds the meme subscription to a picture that was uploaded. And this function executes only when some event within the cloud happens. One example is Cloud pops up message. So there is a message in message queue. The function triggers, whatever, disassembles what's in the message, puts it somewhere. Cloud storage event. The new picture is being uploaded. The function runs, adds the funny signature to the picture. HTTP request on API endpoint, or a webhook, something like this. So again, function runs, you pay for a couple of seconds, it goes down. And also a bunch of events from Firebase. So for those of you familiar with Firebase, that's the mobile development platform, which is also now part of Google Cloud, which allows us also to do the triggers based on analytics, like certain threshold of customer behavior was met based on authentication, customer has just logged into application, and so on and so forth. Also, around all these products from different cloud platforms which run event-driven functions, there is now a movement of frameworks, of serverless frameworks, which allow developers like you build fully functional applications without relying fully on on Cloud Functions or similar products from other platforms. So no servers at all. Everything is completely event-driven. I haven't yet actually seen this in live, but I would really want to see. And Cloud Functions has been recently added as a supported platform for serverless.com. That's one of the frameworks which allow you to do that. So when Cloud Functions would be considered a fit? So what code would you put there? So first of all, something that is serverless by its nature. So after you read a bunch of articles about serverless, you will realize that some specific function or some bunch of functions within your application or within the solution that you're building, they don't actually need a constantly running backend middleware or whatever. They just need to react to a certain event, like a file was uploaded somewhere or a message was received in a message queue. So same as with Docker. At some point within your team, or maybe with yourself, you will see the people who will just say, why would we deploy it on App Engine? Let's put a function on it and let's put a trigger on it to run whenever the new file is arriving. Lightweight ETL, obviously. So like if you need to transform a bunch of text received from somewhere, or if you need to transform even like a bigger data structure, if it's not fit for Hadoop or Dataflow, you might as well do it with Cloud Function with minimal spending. Lightweight API endpoints and webhooks, as I mentioned earlier. So a Cloud Function, when you deploy it, it can be triggered by, for example, some request which it received on a public endpoint. And also as sort of a glue between the cloud services. So again, instead of writing some backend agent which will be sitting there and listening to the message queue and then trying to orchestrate all the other services, Cloud Functions can serve this purpose. So if you need to react to certain events happening within your cloud, and if you want your application to react and other cloud services to react, Cloud Functions is the way to go. The constraints, first of all, right now only single runtime is available for Cloud Functions, so you have to write them on JavaScript and execute in managed Node.js environment. Function level granularity, so usually each function contains only one function, so they are single purpose pretty much. And must interact via events. So you cannot call one function directly from another function. You have to put a message into message queue, and then the other function will react to it. OK, so we have 3.5 minutes left. So where should I run my code? You have to choose the abstraction layer. You have to consider your technical requirements. You have to consider your team. So is your team ready to adopt Kubernetes and work in microservices? Is your team ready to conform to App Engine runtime requirements? And what is the comfortable abstraction layer for you? Do you want to manage VMs or not? Technical requirements move you down the stack. So if you need access to GPUs, for example, for fast processing, or if you need a specific Linux kernel, you will have to run with Compute Engine. If you want to do hybrid cloud, or if you need certain network protocols, you can stick with Container Engine and keep Compute Engine as abstraction. If you have the constraints in terms of what programming languages you want to use and what runtimes you want to use, that's the App Engine moment. Also with team organization. So functions and App Engine are mostly tailored to the teams that are dev-focused. Container Engine are the teams which very well interact with each other, like dev teams, ops teams. And Compute Engine can be used pretty much for anything. We've been running VMs for years, come on. So if at this point, at the end of the conference, at the end of the talk, you find yourself at sort of a moment of making a risky decision, and you think like, okay, if I move this to Compute Engine, will I be able to live with it for the next 5 years and so on? We would like to tell you, don't be worried, because most of the customers and most of the large-scale deployments are actually using a combination. So nobody never will restrict you from running some stuff on Cloud Functions, even more. Most likely Cloud Functions will be like an additional capability for you towards next to Kubernetes cluster or the Compute Engine. High-performance stuff or legacy stuff or customized stuff can run on Compute Engine. Microservices can run on Container Engine. So find the right fit for you. based on this, based on what you will read, based on what we can talk about after the conference. And always be sure that you can migrate between them. Because again, within the Google Cloud, you will use Cloud Storage as a storage, Cloud SQL as a database, or Spanner as a database. And all of these services are very nicely integrated with each other through SDKs, through APIs, and so on. So if at some point you want to move your PHP code off App Engine into Kubernetes, we have tons of customer experience, of customer examples who are actually able to do that. So, too long didn't read. Just quick recap of everything. Cloud Functions, event-driven, single purpose. App Engine, mostly web-facing code and mobile or web backends. Restricted in runtime, but very easy to manage. Just code, no operations at all. Container Engine, modern containerized workloads and microservices architectures. Most likely, if you need it, you are already talking about it, or some other people are talking about it. Compute Engine, pretty much everything else. Lift and shift, control over operating system. Just really like to manage Linux operating systems with Ansible. So everything that you cannot see the fit in the other layers of the stack, we can fit it. That's it for today. Thank you.